Okay, guys, welcome. Today we're going to talk about the fundamentals of probability. Now, the first two concepts that we need to talk about in regards to probability are outcomes and events. Now, outcomes are the most basic possible results of observations or experiments. So, for example, if you toss two coins, one possible outcome would be heads and then tails, and another possible outcome is tails and then heads. Now, an event could be one or more outcomes that share some sort of property of interest. So for example, if you do the two coins tossing and you count the number of heads, then the outcomes HT, heads, tails, and tails, head, both represent the same event, right? Because you have one tail. So as an example, let's consider families of two children. We'll list all the possible outcomes for the birth order of boys and girls. And then if we are interested in the total number of boys in the families, well, what are the possible events? Well, the possible outcomes are, and we'll list these sort of inside of a set, they could be boy, boy, two boys right in a row, or it could be two girls right in a row. We could also have one boy and then one girl. We could also have the girl first and then the boy. So those are your four different possible outcomes. Now, if we're interested in the number of families, or sorry, not number of families, number of boys, then from these outcomes, we can either have 0 boys, that would be this option right here, right, the both girl option. We could have 1 boy, which would be either of these two options. And then we could also have the 2 boy outcome, which would be both boys. So that's sort of the difference between possible outcomes and number of boys for this particular example. Now, when it comes to finding the probability of an event, we usually describe it with probability of whatever the event is on the inside. So it might be probability of boy or something like that. And it's always a number between 0 and 1. And of course, it's inclusive because if you have a probability of 0, that means that the event is impossible. And a probability of 1 means the event is certain, means that it's guaranteed to happen. Now, the first type of method that we'll talk about in order to find probabilities is sort of the mathematical way of doing it, and it's the theoretical method. Now, this will apply for what's called equally likely outcomes. In other words, there isn't an event that's more likely to occur than another one based on some kind of unfair advantage or something like that. So what we do is we count the total number of possible outcomes. And sometimes you might have to list these out or at least some of them out to sort of get a feel for it. And then the next thing would be to then decide among all the possible outcomes, count the number of ways that the event of interest, which will frequently denote A, can occur. And then the last thing that you would do is find the probability by taking the number of ways that the event you're looking for can occur. And then we divide that by the total number of possible outcomes. So for example, we'll apply the theoretical method to find the probability of part A, exactly 1 head when you toss 2 coins, and then getting a 3 when you roll a 6-sided die. So the first thing we need to do is find the number of outcomes when we toss 2 coins. Do we get 1 head? Well, the possible outcomes would of course be when we toss 2 coins, we could get both heads, we could get both tails, we could get a heads first, then a tails, or we could get a tails and then a heads, similar to the boy-girl problem. Now, how many of these events have exactly 1 head? Well, it's this one and this one, right? So then the total number of outcomes would be 4, and the ones that we're interested in would be 2. Right? So it looks like we have a 1 out of 2 or 50% chance of getting at least 1 head when you toss 2 coins. Not at least, exactly 1, sorry, right? Because we didn't want the 2 heads case. Now, part B, what's the probability of getting a 3 when you roll a 6-sided die? Well, there's one way you can get a 3, and there's 6 possible options, so it's a 1/6 probability. Okay. Now, in the next example, they have a figure in the textbook, but it just shows the 52 playing cards in a standard deck. And we'll describe it a little bit here. So there's 4 suits. You have hearts, spades, diamonds, and clubs. Each suit has cards for the numbers 2 through 10, plus a jack, queen, king, and an ace, right? And of course, that gives you a total of 13 cards in each suit. Now, hearts and diamonds are red, while spades and clubs are black. Now, if you draw one card at random from a standard deck, what is the probability that is a spade? Well, how many? So we need the probability of spade here. So in the top, we need number of ways to get a spade. And in the bottom, we need the total. Oops, not 2 L's. Total number of outcomes. Well, there's 13 spades in a deck because there's 13 of each suit, and the total number of outcomes would be the number of cards in the deck, which would be 52. And of course, you could reduce this if you want to 1/4, which would also be 0.25 or 25% you could think of. All right, so any of those 3 would work. Okay, now the next example, we want to know what is the probability that a randomly selected family with 3 children has 2 boys and 1 girl? And again, we'll assume that boys and girls are equally likely. Okay, now let's first list the possible outcomes again. Right, so first we can do all of the same sex. We can have 3 boys, or we could have 3 girls. Right, then we could have all 3 examples with 1 boy. We could have a boy and then 2 girls. We'd have a girl, then a boy, then a girl. Or we could also have 2 girls and a boy. Now all the scenarios with 2 boys, we could have a boy and then another boy and then a girl. We could have a boy, a girl, and a boy. And we could also have a girl and then 2 boys. Right? And that looks like all of our possible outcomes. So it looks like we have 8 possible outcomes. Now, how many of these have 2 boys and 1 girl? Well, it looks like that's this one, and this one. So it looks like we're going to have 3 out of 8 of these possibilities would give you 2 boys and 1 girl. All right, so there's a probability for that one. Okay, now the next one, we want to select a person at random from a large conference group. Now we want to know what is the probability that that person has a birthday that occurs in July. Now we, of course, will assume 365 days in a year, and we'll also assume that every birthday is equally likely. Now there's 31 days in July. So it looks like if all birthdays are equally likely, then the probability is 31 out of the total possible days, which is 365. Right, so that would be the probability that if we select a person at random, that they would have a birthday in July, at least basing it off the fact that all birthdays are equally likely. Now, the next type of probability that we're going to talk about is what's called relative frequency probability. Now, the first thing that we do for relative frequency is we either repeat or observe some process many times, and we count the number of times that the event of interest occurred, right? And then the next step is we estimate the probability based on this data, and we take the number of times that A occurred, and we divide that by the total number of observations that we had. right? So this is really more based off of things that have already happened. So based off of events that have happened. I don't know if that's how you spell happened. I think it maybe has an extra N, but that's okay. Okay, now example 6, geological records indicate that a river has crested above flood stage just 4 times in the past 2,000 years. What is the relative frequency probability that the river will crest above flood stage next year? Well, we observed this 4 times in the past 2,000 years. So it looks like we have a 4 out of 2,000, or if we want to divide the top and bottom by 4, a 1 out of 500 chance. All right, so that would be based on this data that's already happened. Okay, now in the next example, we're interested only in the number of heads when we toss 2 coins. Well, the possible events from that, of course, would be 0 heads, 1 head, or 2 heads. Now, suppose we repeat the 2 coin toss 100 times and we have the following results. We have 0 heads 22 times, 1 head 51 times, and 2 heads 27 times. Now, we know that the theoretical probabilities for this, right, we did this before, right, because your possible events would be heads, heads, tails, tails, heads, tails, and tails, heads. Well, then the probability of getting 0 heads is 1 out of 4, right? Because you have one event that has 0 heads, so that'd be 0.25 or 1 over 4. Probability of getting 1 head, well, it's both of those last 2, so it's 2 out of 4, which is 0.5. And then for 2 heads, it's back to 1 out of 4, which is 0.25. Now, as far as the relative frequencies go, well, in this experiment, we had 0 heads 22 out of 100 times, so that's a 0.22. We had 1 head 51 times, so 51 out of 100, which is 0.51. And then we have 2 heads 27 times, so 27 out of 100, so 0.27. Right? Now, we are comparing these two, and we want to see if we have reason to believe that the coins are unfair. Now, since all of these probabilities are fairly close together, we have 0.25, 0.22, 0.5, and 0.51, 0.25, 0.27, they're all pretty close to what we would expect as far as a theoretical probability. So it's pretty likely that these coins are fair coins and they're not unfair, right? So they're just your average run-of-the-mill coins. Now, the last one is kind of a silly one, but this is what's known as subjective probability. Now, subjective probability uses experience or intuition to predict some kind of probability. So for example, we might say the probability that a friend will be married within the next year. We're not basing it on total number of outcomes or some kind of observed experiment, but it's sort of based on what we think is going to happen. So this is a subjective probability. Okay, so just to summarize, theoretical probability would be based on the assumption that all outcomes are equally likely, and it's determined by dividing the number of ways that an event can occur by the total number of possible outcomes. A relative frequency probability is based on some sort of observation or experiment and is the relative frequency of the event that we're interested in. And then, of course, the subjective probability is an estimate that's based on experience or intuition. So in this next example, we'll identify which method resulted in the following statements. So for example, I'm 100% certain that you'll be happy with this car is certainly a subjective probability. Now, in part B, we have based on government data, the chance of dying in an automobile accident during a 1-year period is about 1 in 8,000. Now, since this is based on government data, this is going to be, of course, relative frequency. Probability. Okay, then in part C, we have that the probability of rolling a 7 with a 12-sided die is 1 out of 12. And of course, that's theoretical because that's just taking the total number of outcomes that you're interested in, which is, of course, just 1, and you're dividing that by the total number of outcomes, which is 12. All right, so that's theoretical. Now, we can also talk about, just as we've talked about calculating the probability of an event occurring, we can talk about, well, what's the probability of an event not occurring? Now, if we know that the probability of an event A is P of A, then the probability that A does not occur would be 1 minus that, right? So you're just taking sort of the opposite occurring, and that's exactly what's going on. Now, if we want to know what is the probability that a randomly chosen family with 3 children does not have 2 boys and 1 girl, right? We found the probability that 2 boys and 1 girl in the previous example was 3 out of 8, right? So if we want the probability of not 2 boys and 1 girl, well, of course, that's 1 minus the probability of 2 boys and 1 girl. So then that's 1 minus 3 over 8, which would give you 5 over 8. So that would be the probability that you did not have 2 boys and 1 girl. Okay. Now, the next thing that we're going to talk about is how to make a probability distribution. Now, a probability distribution represents the probabilities of all possible events of interest. So to make a table of a probability distribution, first things you want to do is you want to list all possible outcomes. And sometimes it's helpful to use a table or figure for this. Then, of course, you will identify outcomes that represent the same event, and you'll find those probabilities of each of those events. And then, of course, we'll make a table in which one column lists each event and another column lists each probability, right? And then this, of course, the sum of all the probabilities must be 1. So now let's make a probability distribution for the number of heads, that's going to be the event that we're interested in, that occur when 3 coins are tossed simultaneously. So again, first, we need to find all outcomes. And of course, all the outcomes for this are going to be the same as the boy-girl scenario, except replace boy and girl with heads and tails. So we can have all 3 heads. We can have all 3 tails. We can have heads, tails, tails. We can have tails, heads, tails. And we can have tails, tails, heads. And we can also have tail, head, head, heads, tail, heads, and heads, heads, tails. So those are all of our possible outcomes. Now, if I wanted the probability of 0 heads, right, then I only get 1 event there, right? That's this one. So that would be 1 out of 8. I could also then get 1 head, and then that would be this one, and this one. So that gives us 3 out of 8. We could also have 2 heads, which would be this one, and this one. So that's also 3 out of 8. And then finally, we could have all 3 heads, and that's the last one. That's just 1 out of 8. All right, so now we can make our table where one column has the event and the other one has the probability of that event. So of course we could have 0 heads, 1 head, 2, or 3. And of course our probabilities would be 1 out of 8, 3 out of 8, 3 out of 8, and 1 out of 8. So that's our probability distribution for this. And a lot of times we'll include a total just to check that this is 1, right? So, and of course, if you add them, you will get 1. So that's your probability distribution. Okay, now in this next example, we're going to make a probability distribution for the sum of the dice when 2 fair dice are rolled. And of course, we want to figure out what is the most probable sum. So first, all the possible outcomes would take too long to list, but I'm going to sort of show you the pattern here. Now, the first possible sum that you can have, right, is 2, because you could have both of them be a 1, right? And of course, I could have the first die be a 1 and the second die be 1, and that's the only way that you can get that, right? So there's one possible way to get a 2 to come out. Now, to get a 3, you could have a 1 and then a 2, or you could have a 2 and then a 1. For a 4, we could have a 1 and a 3 and a 1, or we could have a 2 and a 2. Right? So far it looks like we have 1, 2, and 3 possible ways to get each of these. Okay, now if I keep going, 5 would give me, I could have 1 and 4, 4 and 1. I could have 2 and 3, or 3 and 2, and that would give me 4. So now for 6, we could have 1 and 5, could have 5 and 1, could have 2 and 4, 4 and 2, or 3 and 3. And of course, that would give us 5 possible ways. Now 7 is the big one because we have 1 and 6, 6 and 1, could have 2 and 5, 5 and 2, or 3 and 4, or 4 and 3. So we get 6 ways there. But now we start to go down, because once you start to do 8, you can't have 1 and 7. The best you can do is 2 and 6. So you get 2 and 6, 6 and 2, and then we have a 3 and a 5, 5 and a 3, and then 4 and 4. So now we're back down to 5. And of course, this is going to keep going until we get to 12. Right, so for 9, you have 3 and 6, 6 and 3. We have 4 and 5, and 5 and 4 for 4 possibilities. And then for 10, we have a 4 and a 6, 6 and a 4, or a 5 and a 5. So that gives us 3 possibilities. For 11, we could have 6 and 5, or 5 and 6. And for 12, the only way we could get that is both 6s. So that's 1. Right? So that's sort of everything that's coming out. And I know that I said I wouldn't list all the outcomes, but I ended up doing that anyway. So it looks like our probability distribution will look something like this. So the event is just getting that sum, right? So we could have 2 through 12. Now, if you count up the number of events that you have here, you're going to have 36 total. So all of these numbers are out of 36. So this is 1. This is 2, 3, 4, 5, and 6. And then, of course, we start going back down. So 5, 4, 3, 2, and 1. Right? So, of course, the most probable sum is 7. Right? And that's the idea. Now, the last thing that we'll discuss in this video is the idea of stating the odds. Now, odds are slightly different than probability. Now, probability refers to percentage chance of an event occurring, while the odds are the ratio of the probability that a particular event will occur to the probability that it will not occur. Right? So a lot of times this can be broken up into two different ways. We can either say the odds for an event would be a probability of that event over probability of that event not happening. And then the odds against an event happening would be the probability of not A over probability of A. Now, a lot of times in gambling, you'll hear them use the phrase odds on, and most of the time this means the odds against. So for example, what are the odds for getting two heads and tossing two coins? And also, what are the odds against it? Well, we know that the probability of getting two heads when you toss two coins is 1 out of 4. And the probability that you don't get two heads would then be 1 minus that, so it would be 3 out of 4. Well, then the odds for two heads would be probability of two heads over probability of not two heads. So then that would give us a 1/4 over 3/4. And if you remember how to divide fractions, that means we have to do keep, change, flip. And what will happen here is you get a 4 over 12, where you could cancel out the 4s and you get 1 over 3. So the odds for two heads are 1 over 3. Now the odds against, of course, is the other way around. It's probability of not two heads over probability of two heads. And of course, that would mean that we're going to flip this when all is said and done, and we would get 3 out of 1. Right? And you can check that if you were to plug in the actual numbers and do keep, change, flip again, that's what you would get. Okay. Now, in this last example, we have that at a horse race, the odds on Blue Moon are given as 7-2, right? So this is odds on, and remember that means odds against. Right, and they're given as 7-2. Now, if you bet $10 and Blue Moons win, how much will you gain? Well, let's think about what the odds against mean. Right, so that means that we have the probability of not A over the probability of A. And they're giving us to that as 7/2. Right, so they're telling us the probability that this horse doesn't win is 7 out of something, and the probability that it does win is 2 out of something. Now, if we bet $10 and this horse wins, then we need to solve this, right? Because both of the events in the bottom represent when Blue Moon wins. Right? So now we need to capitalize on this sort of the 7 here. So when we cross multiply, we're going to get 2x is equal to 70. So then we get x is equal to 35. So if we bet $10 and this horse wins, then we would win $35. All right. So that concludes this video on the fundamentals of probability. I hope you enjoyed, and I'll see you next time.